Perfect. Well, yeah, look, thanks for coming along to this meeting today, guys. We have some pretty incredible people as club members down here, and part of this has been really fun to catch up with them and find out a little bit about them and, get some of that information out to you lot. So today we've got Geoff Comfort joining me just 1.5 metres away here, and a couple of club members in the background who were coming past and managed to score the live hot seats down here at the club. So, yeah, look, Geoff, thank you so much for joining us today and chatting a little bit about boat work and things. And I'll just ask you a couple of questions about your own sailing. When did you start sailing?
Thanks, Steve. I started sailing down here in mid-1960s in a Sabo and then a Mirror. And I know Peter Forster from that time. We sailed in sea flies together. And then I sailed an OK dinghy, sailed that for a while, and then I got into boat building, moved to Sydney, ran a boat building business up there for a long time, building a wide range of boats. Started off with first production vacuum moulded foam sandwich boats in Australia, which was the Taser, and ended up building high-performance rowing shells out of carbon and no-mix honeycomb. So quite a lot of interesting things there. And then I had my midlife crisis at about 40 and changed to be a photographer. So I run a photography business now, and I still come down here and do some boat repair work from time to time. I quite like doing it, even though some of the materials aren't all that pleasant, but I am pleased with the result that we can get with repairs on these boats down here. So today I'll talk to you about some of the repair techniques on a couple of specialised areas we're looking at, but I'm really happy for you to just interrupt any time and ask me any questions about this. There's no secrets as far as I'm concerned. Happy to tell you whatever you want.
Fantastic. And looking around at some of the participants, I think we've had quite a few of us have had our boats repaired by Geoff over the years, me more than most. So, yeah, that'll be fantastic to get into that. So the structure from here is we're going to do a bit of talking inside where we've got really good audio quality. We thought we were going to have a nice quiet day out on the grass, but about half of Canberra has joined us down here today. So we may struggle with audio once we get outside. We'll do our best, but we'll be doing some practical repairs on the boats out there as well. Yeah, Geoff.
Okay, so I just made a few notes here which I can refer to as we go along today. We're going to deal principally with repairing GRP boats, glass reinforced plastic or fiberglass repairs. Before you do that, you need to understand what your boat is made from. If it's made from wood, that's pretty obvious. You can have a look at that and work out how to repair that. And I do repair wooden boats occasionally, but there's not many around to repair. Most of my work is repairing fiberglass boats, for want of a simple term. And the important thing about those fiberglass production boats is that they're made with a polyester resin system, which is a pretty common resin system. It's pretty cheap, it's very effective, and I would think that in Canberra, with the exception of some of the high-performance rowing shells, nearly every boat that we're sailing in are made from fiberglass. The other thing to be careful of is some of the cheaper canoes and so on are made of rotomolded plastic, and there's a different repair technique required for those. I can't do that, but some of those boats can be welded together if they have broken. I have repaired them successfully with epoxy resin, but it's a bit of mucking around to get it to stick on there properly. So we're going to look basically at glass reinforced plastic today. So standard boats like that are Flying 15s, lasers, tasers, probably all the trailer sailors. But within those range of boats built with that material, some of them are solid fiberglass, like Paddy's boat, that's solid fiberglass. And some of them are foam sandwich boats. So some areas of the laser are foam sandwich boats, foam sandwich construction. Some of the newer Flying 15s have some foam sandwich construction in them. Some of the older boats might be a sandwich construction with a balsa core instead of foam. And so I don't know if you're familiar with foam sandwich construction, but basically there are two layers of fiberglass with a piece of foam inserted between the two of them, and they're laminated like that in the manufacturing process. They have the effect of being very strong for relatively lightweight and very stiff as well. So they're a bit like an I-beam, a steel I-beam with two plates on the outside of a web, which gives you amazing stiffness. And that's the main reason for making foam sandwich boats. And it's especially effective in boats that don't have very good form stiffness. So things like Sharpies, lots of big flat panels on them, don't have a lot of form stiffness in them. Something like a laser, because of its curved hull shape, has got reasonable form stiffness in the hull, which is why the hull doesn't have much foam in it. 505s were quite successful as solid fiberglass boats because they've got quite a rigid shape, but because of the level of racing that's going on there. Now, most of those boats are built with very high performance materials, epoxy, pre-preg carbon, and vacuum moulded construction. Very expensive boats to build, but we're going to talk mainly about fixing fiberglass boats here today. So you need to know what you're working on. It's highly unlikely your boat's made out of epoxy. If it is made out of epoxy, you need to repair it with epoxy. If it's made out of polyester, which is most of the boats we're dealing with, you can repair them with polyester-based products, or you can use epoxy if you want to as well. The problem with using epoxy to repair a standard fiberglass boat is that you can't put a fiberglass paint over a polyester paint over the top of that. So it's generally better on a fiberglass boat to stick to a polyester repair system throughout. So those polyester materials would be polyester resin. You see that? There's a tin of polyester resin there. You know, it's smelly stuff. It's not very expensive, and it is activated with a catalyst. So one of these little bottles here. Can you see that? Where's our picture?
We're just here, yeah. So that's what's there.
Oh yeah. So just a very small amount of hardener, typically 1 to 2% for making a production boat, but for repairs probably up to 5%. And you need to be very careful in Canberra. All of these materials are temperature sensitive, and you want to be very careful about using them in cold and damp conditions. So as Darryl said, he's built up a heated room in his garage to work in so that you can elevate the temperature. That's pretty good. One of the good things about using polyester resin is that it does go hard or sets pretty quickly. You can get it set in a couple of hours. So you can do repairs outside in Canberra in the winter on a sunny day, and it'll be dry enough. You'd have trouble with epoxy, even with fast set epoxy, you'll have trouble getting that to go hard. So that's why you really need to heat that up and keep it heated. I've just got a couple of examples here of a couple of different fiberglass materials. So that's fiberglass cloth, generally used in higher performance dinghies over a foam sandwich, and this is chop strand mat. So this is just random bits of fiberglass sprayed together and held together with a PVA binder. The advantage of this stuff when you put the resin on it, this is reasonably rigid now. When you put resin on this, the resin dissolves the binder and it goes very soft and will go into quite complex curves. With the cloth, it's very hard to get that to go into complex curves. So most of the repair work I do is done with chop strand mat. If it's a large flat area, you can use cloth and the repair is light. So on high performance boats, I would use cloth in preference to the chop strand mat. It uses less resin, but there's a few skills needed to get that down properly. The other option to this, of course, if you're looking for minimum weight and maximum strength, is to use carbon fibre. You can use carbon fibre with resin, polyester resin or epoxy resin. Just make sure, it's unlikely that you would have it. There's stuff called pre-preg carbon fibre, pre-impregnated with epoxy resin that needs to go in an autoclave to cook it. So heat and pressure then to make that go hard. You probably won't find any of that, but just be very wary if you end up being offered any of that. You may not be able to use it for a repair. So any questions so far with what we've discussed there?
Geoff,
okay.
Geoff, John O'Donnell. The Hobies are all a fiberglass sandwich construction. So you've got a fiberglass outer layer and then a sandwich of foam and then an inner lining. Have you done much work on those?
I've done some Hobie work, but it's very similar to work I've done on other boats like Tasers, and we're looking at a Sharpie outfit today.
Yep. Okay, cool.
So, and one of the reasons that we've chosen to do some fiberglass repair work, foam sandwich repair work, is that there's quite a few foam sandwich boats around, And people will have found that during the hailstorm, if you had your boat down here, the outer skin got damaged and the foam got crushed, and sometimes it penetrated through the other side of the skin. So on your Hobie, there's a big problem if something like that has happened, getting access to the inside of the boat to repair the broken skin on the inside before you build it up. Yeah.
Actually, in that storm, mine was damaged. There was no outside damage to the fiberglass, but the shock of the hail hitting the hulls dislodged all of the sandwich inside. So you couldn't see anything. You couldn't see anything visibly, but when you pressed it, it was all really soft. So that was all covered.
Yeah. No, so they're tricky things to fix when you can't get to the other side of them. And there's been, as Sarah knows, there's been quite a few boats written off because the extent of the hail damage was very expensive to fix and more than the value of the boat. So that was lucky that people had those insured there. Yeah. So I'll just mention briefly this resin that we use, polyester resin. So, and I think my preference is to go and see ACD fiberglass suppliers. They used to be in Fishwick, now based in Turner. They've got a really wide range of epoxy, polyester, and carbon and chopstone mat and glass cloth. So you don't get much in Bunnings, but you certainly get enough to fix the repair. You probably can't get a material that is suitable for finishing the outside of the boat, and that's something we'll talk about towards the end of today's presentation. But I think we should move outside, and we'll just go and have a look at a Sharpie out there. As Steve said, there's a lot of people around here, and I'm not going to do much grinding down here now with all these people around. But I'll show you what we can. There's a couple of repairs out there we can have a look at. So I'll see you outside in a couple of minutes.
Perfect. We're just going to mute and turn the mic off, and we'll be back on in a second. Alrighty, so we're outside now. Just a disclaimer that this is not an elaborate plot to get Geoff to work on my boats. We chose two boats at complete random, and they both happen to be mine. But we're going to have a look at those now. I'll just turn the camera around. While you've still got me here, just a word on safety, and Geoff might add some stuff to this, but we are going to be demonstrating, using some interesting materials and some power tools, and make sure you're appropriately trained and wearing the appropriate, personal safety gear if you are doing any of this. You'll see that Geoff's got some excellent stuff for that to display. Turning the camera around, and we're looking at you now, Geoff.
Okay, let's go and look at the boats. So this is some extreme examples of hail damage. You can see this is a boat that I built about 30 years ago, and it has quite a thin outer layer. It's a foam sandwich boat. If you can see the cutout here for the compass, you can see the foam in there, two thin layers of fiberglass. So it's quite rigid and quite light, but it doesn't tolerate hailstones very well. So this boat is riddled with hailstone damage all over. So I'm just going to show you one that I have prepared earlier. So what I've done here is, it was a hole that was similar to that. I've cut through the top layer and peeled that off. Then I've chiseled out very carefully so I don't damage the bottom layer of glass, which is the inner skin on the foam sandwich boat. And now I have cut up a piece of foam. So this is, I have to say, this is the right way to repair a foam sandwich damaged boat. I'll insert that in there with some putty. When the putty's gone hard, we'll grind that down and glass over the outside of it, and then grind that down and fair that up. So this hole here, you can see that, Steve, is an impact hole with a hailstone. I've ground this down a bit. This is a common way for people to repair hail damage. Just put a bit of filler over that and then sand it down a bit more, put some glass on it and paint it. What hasn't been removed in here is the damaged foam. So this system here is the better way to do it. It's more work, bigger area to fix, but we end up with a much better job. So when we glass over this repair here after it's been filled, it's quite likely that we'll get some blisters in the deck because what's underneath is compressed foam. It's lost its strength, it might pop out, might get some moisture in it. So that's not the best way to fix it. This is the best way to fix it.
Perfect. Just going back a stage there, Geoff. So you actually built this boat. Where was this boat made?
This is built in Sydney.
Sydney?
Yeah. Business up there. I've built quite a few Sharpies and built some round bottom Sharpies, which cause a lot of good.
Perfect. Yeah.
Conventional Sharpies.
Still very highly sought after boats. Couple of loopholes in the measurement laws back then. Still going strong. But This one, not so much. We're going to try and get it back on the water.
So I talked about materials inside, Steve, and this is one of the really good materials. No fancy name, just called Builder's Bob. It happens to be a very lightweight polyester quick setting putty. Builders use it for all sorts of things. You can use it at home for sticking raw plugs into the wall if they spin around and put screws in and so on. This is really good. It's a really good product, much better than Plastic-On. And once again, it's a polyester resin base with some fillers in it, and it has a hardener here. This hardener's coloured, so you can see it when it's mixed through the putty properly.
And not too much of a scientific measurement there on how much hardener to bog.
No, they are in fact quite honest about what you can use there, and they recommend anywhere between about 2 and 10%. So if it's cold, you probably want to bump it up a bit, otherwise you'll be here for a long time waiting for it to go hard. So you can see now that we've got a pretty even colour through that, but the last thing you need to do is check that the stuff that's on the putty knife is mixed, and you can see where I've scraped with the putty knife. There's a bit of white stuff there, so we just need to mix that in there because we need this to be mixed all the way through. This will gel, so it can't be spread in about 5 minutes in the sun. So we don't have very long to work with it, but that doesn't matter because so all I'm going to do with this now is just make sure that we've got it bonded in this hole in here. I'm going to put plenty in there and squeeze it out. We want to make sure that it's bonded all over. It's not great stuff to have on your fingers. I haven't got any gloves on because I'm reasonably good at not ending up with too much of this stuff on me. But you know, if you've got an allergy to any of these things, just be careful. So you can see what's happened there. By pushing that down, we've squeezed that out all the way around the edge, and that's the confirmation we want to make sure that it's bonded properly down there. So we'll just take that excess off, because the other thing that you don't want to do when you're doing these fiberglass repairs is leave a lot of excess around, because you've only got to sand it down. If you can keep this pretty neat, you won't have a lot of, you can minimise the amount of sanding you've got to do. So basically you want to, if you're using filler, generally you want to underfill things, and then you won't be grinding stuff off. So you can see that's been a bit of work to put that in there. This other repair here, I'll just grab my chisel, Steve, and we'll just take the junk out of that. We've already ground it down a bit, as you can see. We'll just take some of that broken stuff out, broken glass and broken foam out of there. And we can just fill that with some putty. This is not the recommended way to do it.
But probably the way I'm going to fix the rest of the boat.
Quick and dirty. All right, so that's starting to thicken up already. So that's what we need to do with that one for the moment. When that's gone hard, properly hard, in about half an hour or so, we could come back and grind that down. We want to grind this down so we just get down to the foam out here, and make sure this is kept below that level as well, because we only have about 1 millimetre of glass to put on this. It's not very much. So on a laser where there's it's quite a thick glass laminate, you can put a lot of glass on. But on boats like this, these more sophisticated boats, you have to be very careful about what you put on there. I would repair this with cloth now, but I will also find a way of, you could vacuum it down, but I need to put some weight on it to push it down hard, so that when we sand this off, it's glass, it's smooth, and it blends in with the rest of the repair that's here. And you could put the same sort of glass over the top of this repair that's here.
Perfect. And Steve Swinsberg's just asked a question on the chat. He missed what was that rectangular piece that you filled the hole with there, Geoff?
Oh, it's a piece of rigid PVC foam. I don't know, Cledgecel, Aerex, those are some of the brand names that are used now. And that's what the boat's made from.
So that would be the original layer that was between the two fiberglass layers that creates that I-beam.
You can possibly see it there.
See
where that's been cut out there.
See the two layers there? So that gap between the two fiberglass layers is what gives us our strength.
So Steve, I'll just tell you the other thing you need to do is, while you're doing this, is just keep all this stuff clean. It's much easier to get all this stuff off while it's wet, rather than having to clean it off when it's gone hard. Okay, so that's pretty right. That'll just need a a light sand down when we come to use it again, and it's ready to go. Perfect. Didn't need any salt. Okay. So that's what we've done there, and yeah, it's started to gel already. There's the bit that I threw away. That's the bit of waste, and you can see I can't squeeze that very much now. So even in this weather, in winter, it's
really,
going hard quite quickly.
Really quite quick. Yep.
Yeah. Okay.
Perfect.
So this is Steve's boat. Steve will have to work out what he does with this, but for me, this is uneconomical to repair.
This is what would be a write-off if it was insured. Unfortunately, it's going to be an education instead. That's okay.
All right, so I'm not going to grind this down, but what we would do after this has gelled properly, maybe half an hour, an hour, we would grind this down, as I said before, use some resin and cloth to repair this and push it down into there. So that would give us a boat that is structurally sound. Now, one of the things I just want to say about the Hobie is the Hobie's foam sandwich. The Hobie has much, much thicker outside skin on it than this boat does here. So even foam sandwich Hobies are still quite heavy. So you've got a fair amount of glass on the outside you can play with there. Perfect. Let's go over to Steve's other boat.
A Sharpie we prepared earlier.
So this is something that I have been working on with Steve for a while. So this boat is very light, but it's very light because it's got very thin fiberglass on it. It's not foam sandwich. It's got a couple of ribs inside it to keep it rigid. So this is quite difficult to repair because it's only about 3 millimeters of fiberglass. So what I did with this, I'll just get a piece of foam.
No worries. While Geoff's getting those ingredients, I'm just going to walk you over to a third Sharpie that we have sitting here. So that repair you're looking at was trying to repair these sort of stress cracks that we've got here. Can everyone see those? So we've got some stress cracks there, and in the same position on this boat, we've done some fiberglassing, or Geoff has done some fiberglassing to try and eliminate those stress cracks.
Thanks, Steve. So the problem here was that these two pieces of fiberglass on the deck here where they've cracked, so there's the deck and then the side deck meets, when they've broken, they didn't line up. So they were like that. If you had a foam sandwich boat, you can probably fudge that, but on this we had to get them to line up again, which is quite difficult to do. So I used some more of this foam that we use for repairs and had a finish bit about 9 or 10 millimeters thick, put some builder's bog on it and a screw in the middle of it, and pushed it through a hole that I made and then pulled it up inside. And it's underneath there, holding this up and holding those two pieces of fiberglass level now, which has given us a base to work on. It's very hard to fix thin fiberglass laminates without any. Now, I'm not going to do this now because of all the people that are down here, but I would grind this down very carefully now so that it's flat. I did tell Steve when we fix this, we'd probably leave a little mound on here, but if we feather it out to a large area, you will tend not to notice what's happening there. And then we'll go ahead and paint it. So, any questions with what we've done so far before we talk about finishing these?
Any questions there, guys?
Yeah, I've got a couple. It's Daryl here.
Hang on, we'll just turn the camera around, Daryl. We'll be able to see you as well, potentially. No, that's Alf. There we go.
So on top of your glass repair there, have you put anything like peel ply or something on the top to keep the glass compressed while it was setting?
I haven't on this.
While the resin was setting? Yeah.
No, I haven't on this, but on the Sharpie repair, I would probably, on small repairs, you don't need to use peel ply. I just use a piece of timber with sellotape on the back of it, just something that will release it, and just push that in there. It's you can easily put something on there to push it down. So it might be a piece of plywood, some sellotape on the back of it, pushed over the wet glass, and on something like that, because it's a raised surface, you can probably just tape it down, and that'll be enough to push it down, or you can put a brick on it. But with those very thin laminates, you're right. What we've got to do is try and get the glass pushed down, because when we come to fair it in, we don't want to sand all that glass off that's been sitting up too high.
And so just another way of achieving that, isn't it, Geoff? It's just a way of having a really smooth surface. Yeah.
Sellotape's true.
So the other observation, Geoff, and this is sort of a Dorothy Dix question for you. When you were talking about the mix ratios with the polyester and you've got 2 to 10%, I once lent some epoxy to somebody, and when it came back, half of the base was still in the bottle, but most of the hardener was used.
Yep.
And can you talk to us about, if you were doing these repairs with epoxy, the importance of the mix ratio compared to?
Well, that's it, Merrill. It's important. It's essential, I think. You know, they're far more, they're far less forgiving. I don't know what the balance point is, because not everybody gets 2 to 1 or 3 to 1. I try to do it. I weigh it. I weigh my epoxy when I use it. It's got a specific gravity of about 1, so you can weigh them out at a 2 to 1 mix or something like that, and you'll be pretty close to being right with it. I don't know how much tolerance it's got there, but I would always try and stick to the mixing ratio that's required for epoxy. And you need to be very careful with different epoxies, because some of them are 2 to 1, some of them are 3 to 1, some of them are 1 to 1. So make sure that you have 2 things. You need to have new stuff, because it goes off, and you need to have good stuff. There's some epoxy around that's not really very good. I think the West System is probably the best stuff around. That's what I use, and never have any problems with it. But I do mix it very carefully. But following on from that is what I said before. It's much harder to get it to cure in lower temperatures. So what you're doing by creating an oven or a hot space there, what's it up to? 20, 25 degrees, something like that?
Yeah, 25. Yep.
Yeah, but that's a great ambient temperature. You won't have any problems in there doing that. You couldn't make these repairs out here with epoxy on a winter's day like this without putting some heat on. Yep. The other thing I didn't mention when we were inside talking about the materials, if you want to use chop strand mat, which is useful and cheap and flexible, you can't use it with epoxy resin. It has, as I said, it has a PVA binder in it that holds all those little fibres together, but the binder will not dissolve in epoxy. It'll only dissolve in polyester. Okay?
Just learn something.
Yeah, it'll stick together, but you won't get it to go around corners and so on. Yeah. So if we go back to this finish here, this job here of Steve's, we grind this down very carefully. Once again, I would use builder's bog on that to fair it up. And in order to get it straight, and my sanding down for these things is always done with a large block, maybe an orbital sander, but something about this size. If you start sanding this with a pretty small piece of sandpaper like that, you just end up with all these bumps in it, which might be okay for you, but because I charge people to do these things, I want them to look right. So once it's got the filler, sand it down with a sandpaper block. Filler's obviously much easier to sand down than this is. And then we can consider how we finish that job. Perfect. So we might just go back inside, I think. And Laurie, this is 60. Doesn't matter much. Coarse.
Yep.
Coarse. You know, see the little number there, 60.
Yep.
So 24, 36, 60, 80. But for this first stage, probably around 36 to 60. Yes. You know, got big rocks on it.
And we've just got a few questions coming up in the text chat here. So one was, where are we? Steve Swinsberg. What if the hole is all the way through, i.e. a screw hole that is pulled out of the hull? What materials would you use? And it's good that we're using my boat here, because we've got a hole just here that may be able to see. So how would you sort of block that up before you started filling a hole like that, Geoff?
Well, it depends a bit, Steve, on where the hole is. If it's below the waterline, I think you need to treat it very seriously. Mm-hmm. If it's cosmetic like this, it doesn't matter that much. So below the waterline, I would be putting a mould on the outside, just taping a piece of plywood or something like that with some tape on it, mm-hmm. and putting some fiberglass through on the inside that'll go through the hole if the hole's about 10 or 15 millimetres across. Yep. And then grind the outside down and put some fiberglass. Below the waterline, I think that's essential for something like this here, which is fairly cosmetic. And I would just put some filler in there. Once again, builder's bog. When that's gone hard, if you wanted to glass it, just grind around there and put a little bit of glass. If you put a filler in there, often what will happen is over a period of time, the filler will open up slowly from the existing substrate. So glassing over the top of it's probably pretty good. Very Although good. If you were to use a thickened epoxy resin in here and got a countersunk drill bit, countersunk both sides of it, and put it through like that, you'd have something keyed in really well, because you've got these two V'd surfaces like that. Perfect. That won't go either way. Yep. So that's the way to do that.
Cool. And question from Dylan here. We've got, when would you decide to reglass stress fractures? So, you know, I guess the question is, what's the difference between little lines in the gel coat and underlying damage in the fiberglass, and how do you tell between the two?
Well, I think, Dylan, that's a really good question, because it does happen on lots of boats. Lots of boats will go through life with stress fractures on them, and it won't actually cause any big problems. Let me just show you why you get them. We just happen to have a whiteboard here. Cool shackle pin there for something.
Shackle pin.
So, Dylan, when you make a boat, if we've got a mould like that, the first thing and this is the mould support out on this side, and the boat is going to end up on this side. Okay. The first thing you do in a mould when you make a boat is put a layer of gel coat in. That's the outside colour of the boat, and that is often sprayed in on big jobs. Sometimes it's brushed in. Then you would put a couple of layers of fiberglass in there, like that, polyester resin and probably chopped strand mat, maybe backed up with some cloth. At that stage, you might then go and put some foam in there. Foam comes in flat sheets. It's fairly rigid, so it gets a bit tricky to put it in there. Sometimes you heard Darren talk about a vacuum bag. Sometimes you need a vacuum bag to pull it down. Push that into the outside skin of the boat with some adhesive underneath it. When that's dried, you then go and put another thin layer of glass on the inside. So that's the way that you make a foam sandwich boat. If you want to make a solid glass boat, that's the mould, as we discussed. That's the gel coat. And we have this thicker layer of fiberglass around here. Solid fiberglass.
And that would be a laser? It was made
yeah,
with
typically
that much
a laser.
foam?
A lot of trailer sailors are made like that as well.
Yeah.
And generally, you won't get stress fractures on these round sections because they've got good form stiffness in them. But if you've got a flat section of a solid fiberglass through there, that's where you're likely to get stress fractures, probably around a corner if it's moulded into the deck, or maybe around a reinforcing beam underneath. So in Steve's boat here, there are 3 beams that run fore and aft underneath that. They're like what's called a top hat section. So they've moulded in there with fiberglass over the top of them, and typically you get stress fractures around the edge there. Sorry, it works around the edge there, and the stress fracture appears on the outer skin out here. Generally, they're not a big deal, and but on these boats with very thin laminates, you'd want to be pretty careful with it. You'll probably find you'll have stress fractures for a long time, and then one day it'll crack somewhere all the way through. So you can keep an eye on it. I wouldn't bother trying to fix them if they're there generally. Mm-hmm. It's just too much work. They'll probably keep coming.
Perfect.
The reason there's a problem with stress fractures is that the outside skin of the boat, which is gel coat, is about 0.5 of a millimetre thick, and it doesn't have any reinforcing material. So it's just resin with a pigment in it, basically. And that's why it fractures. If you look at high-performance skiffs, they're not made this way. They're made without any gel coat on them. So the outside skin there is just carbon, and they're painted. So their outside skin, outside colour, or paint is very thin, maybe 0.1 of a millimetre to keep the weight down. Mm. So they tend not to get stress fractures, but it's common in fiberglass production boats, around corners and around reinforcing points there. They're quite difficult to fix because you have to take out the cracked gel coat. So if we enlarge that, there's the gel coat and there's the fiberglass substrate underneath it. That's the gel coat there. And if it's got a reinforcing piece underneath there, there's probably a crack in the gel coat through here. You have to grind out the gel coat down to the fiberglass. If you just take the surface off, you've got the crack underneath and it comes back pretty quickly. And my advice is generally grind that out, put some glass in it, sand it down and work it up from there.
Perfect.
It's a lot of work to do. I think you're better off just going sailing.
Just going sailing? Yeah. Yep. Until you can actually see into the back tank like my boat. Yeah. Yep. Perfect. Very good. So, any other questions while we're outside looking at boats physically, guys? Dylan just said thanks.
I'll happily have a look at his boat.
Yeah, no worries. So Mark Webb has just asked, I have some screw holes I wish to fill in the cockpit, but I cannot get to the back of the holes. How should I fill them?
Well, Mark, what you need to do, you won't like me saying this, you need to drill the holes out a bit bigger first so that any adhesive that you put in there is going into really good fiberglass that's not had any silicon on it, not had any dirt or water on it. So if you've got a 3/16 hole, you might want to drill it out to, so it's a 4mm hole, you might want to drill it out to maybe a 6mm hole. Then you know that you've got some really good substrate that you're putting the adhesive into. I would then countersink the outside of it so that the hole diameter is 6mm, the countersink section might be 10mm. Mix up some epoxy and just work it through there. If you can't get to the other side of it, you can't see what happens in there, so it can run down and might just sit on the bottom of the boat. That doesn't matter. But at least you'll be able to work it through and make sure that it really is stuck on there properly. Once again, I'm happy to have a look at your boat and see if there's a way in or another way to do that. Certainly these things are best repaired if you can put a backing plate or something behind them. But if it's in the cockpit, it probably is not as important as below the waterline, although I do accept that the cockpit gets wet and you might get through it. But that's what I'd be looking at there.
Perfect. All right, we might wander back inside, see if we can get the audio working on the laptop. In the meantime, if you guys can think of any other questions, please get them ready, and we'll see you again shortly. How are we going there for audio, folks? All good? Perfect. Thank you. Please feel free to unmute at any time and ask questions verbally as well. Oops, didn't mean to raise my hand there. So we've got one from Bruce McLennan. What was the question there? No, not sure about that one.
I think that was a reply to my one, Steve. So I asked if there was enough interest, would you be willing to run some hands-on workshops to teach us some basics?
Cool. Well, you don't want to learn from me, so I'll turn that one over to Geoff. But
yeah.
Yeah, no, look, I'm happy. I'm happy to do that. You have to remember that if we ran that for an hour, that's not going to address a lot of the things that need to be done. And like all of this stuff, I can tell you all these things now how to do it, but there's something about having done this for 20 or 30 years that makes a lot of this stuff much easier for me to do. I'm happy to show you how to do it. But just remember, this is the stuff's tricky to use sometimes, and if you glued a piece of wood on your wooden boat in the wrong place, you can plane it off and probably start again. If you put the fiberglass on incorrectly or it doesn't go hard, I think the consequences of trying to fix that are much greater. So I'm happy to talk to you about that if you think it's worthwhile. It's messy too, that's the other thing. There's a bit of grinding, there's a bit of resin around the place and so on. But look, I can talk to Steve. Happy for you to talk to him about that and we'll see what we can do. So the final thing I just wanted to talk to you about now is that we've gone through that fiberglass repair process, whether it was a solid fiberglass boat or a foam sandwich boat, using polyester resin and polyester filler. So we've basically, on these repairs, we've got polyester all the way to the surface. So the polyester is now the substrate. We need to finish that off somehow. So we've got two options there. One is to apply something like the original gel coat, which when I explained, that's the first thing that is put in the mould when the boat's built. There's a couple of problems with that. Colour matching is difficult, and colour matching in Canberra is very difficult, especially if you've got a white trailer sailor that's spent a lot of time on the lake, because it's no longer white. It's gone this brown colour. I always paint my repairs, irrespective of which paint system I use, to match the existing paint colour. So sometimes these repairs look obvious, but there's a repair outside here on a VX that I did in January, and it was really white when it was finished, and now it's come back to being about the same colour as the rest of the boat, as it's progressively gone brown from being in the lake. So that's a thing you need to be careful of. Another problem using polyester gel coat, which is the original material the boat was made from, is it's got a sticky surface on it, so you have to put an additive in there, which in Canberra you can only get from ACT fiberglass suppliers. It's called wax solution. So you put that wax in there, And when that gel coat dries then as the final finish coat, it will not be sticky and you can sand it down. The reason it stays sticky is that in construction of a boat, it needs to be sticky to accept the next layer of resin and glass that goes on the boat. So if you want to use it for repair work, it's tricky to use. And the final thing I'd say about using gel coat, it's quite viscous. It's thick stuff. You can't brush it out like you could some enamel paint. So, and this is where these repairs get difficult. My preference with these repairs is to spray them. And spraying catalysed polyester gel coat is quite an art, that you don't have all the stuff going off inside the gun and wrecking your gun, but also that you can feather it out enough so that you don't have too much work to do sanding it off. So that little hole that I showed you on Steve's boat, which was about the size of a 50-cent piece that we just filled, by the time that repair is finished and painted, it would probably be 40 centimetres across or something like that by the time I've sprayed it and blended it in and polished the boat. It ends up covering quite a large area. But that's the way that I do it to get a very smooth and fair finish on the boat. Did you show them a picture of the Irish frog, the repair on there?
We briefly had a look at
yes.
the stress cracks in the transom, and there's some fiberglass next to it. Yeah.
So the other option is what that other Sharpie had on it. There was some cracks there. They just put fiberglass on it and they left it as that. It's a lump on the top of the boat. It doesn't look pretty, but it's strong. And it was a quick way to do it. So if you want it to look like the builder had intended it, there's a fair amount of finishing work required. My preference for a lot of finishing work now is to use a two-pot paint system, a industrial paint system. The colour matching is much easier because it's like going to Bunnings and getting them to match a colour chip, which you can't do with gel coat as easily. And that paint system is used for panel beating cars. So if you know anything about panel beating cars, the whole filling and painting system for panel beating cars is an amazing system. It really works well. So you fill it as we did with polyester filler, then you would sand that down. It now has coarse sanding marks in it. You'd buy a very fine polyester filler, put that on, which will fill the sanding marks. You would then sand that down again, spray an undercoat on it, sand that down again and spray gloss over the top of it. So every time you do that, you can see the repair area just gets bigger and bigger and bigger. And there's quite a large area that you need to feather in. And it's pretty time consuming, but I'm repairing boats to a very high standard because that's what people have paid for. And then once you've done that, wet and dry it down with, depending on how well you finish it, I spray it and can wet and dry it down with 600 wet and dry, go up to about 2,000 wet and dry, and then polish it with a buffer and a cutting compound. And then work on that with what's called an anti-swirl compound afterwards to take the buffing marks off. And it probably looks shinier than the rest of the boat. Okay, so I'm happy to talk to you if you've got any questions, but that's basically the process I would use for going through and repairing holes in boats.
Perfect. Any questions there, folks? Try and unmute your mics and ask them verbally if you've got any.
Geoff, can you just tell us a bit more about the sanding fillers that you use? You were just using the builder's bog, but the sanding fillers, is that a primer filler?
No, it's another polyester. It's another polyester filler, which is available from a crash supply shop. But it's very runny, self-leveling, but it's very fine because these fillers have got. They're filled with like industrial talc or micro balloons or something like that. They're actually quite coarse. And when you sand, you can't sand them to a very smooth finish. So if you buy this final filler, which is almost, it's about the consistency of warm honey, I suppose, you mix a hardener into it, put it on there, and then sand that down with probably 240 wet and dry. That's the base, dry probably. I would use that as the base then to spray undercoat over the top of that and then gloss over the top of that.
And will that sit on an epoxy finish?
Sorry?
Will that sit on an epoxy finish? I just heard you talking about mixing epoxy and it will, okay.
Normally polyester won't, but once again, these materials used for smash repairs are really quite comfortable with most substrates.
Geoff, Martin speaking. First of all, thank you very much for the talk. Can you can you just explain what you use for grinding? You mentioned grinding separately from sanding and wet or dry. I haven't got a grinder at the moment, but anything to make life easier. What do you use for grinding?
What do you want to grind, Martin?
Well, if I was doing the sort of repairs that you talked about and showed us, such as in fiberglass and gel coat, just to get it down in depth, or even to remove any excess filler that I put in. Are you talking about using a machine?
Yes, initially a 4-inch grinder with maybe a grinding disc on it of about 24 to 36 grit, something like that. That grinds very quickly. You want to be very careful if you're going to any foam sandwich with that because it'll tear into the foam. But used carefully, it's a quick way of grinding it down. And I'll probably don't do much grinding after that, except just lightly on the top of the layer of fiberglass that's been put on. And after that, there's a lot of hand sanding on a block so that we get this flat and level, fair to the shape of the boat at that stage when the glass has been done. So I use a block for sanding all the way up to about the 600 wet and dry. And at that stage, the paint that's going on is not that thick, so you're not likely to get too many ripples. And you get a few bumps and so on, but not too many.
Thank you.
Okay.
Good. And we had a
Alf had one.
question here in the room from Alf, actually. Yep.
Sure. Now, we've been talking a lot about, and thanks again for your talk and demonstration as well, we've been talking a lot about the repair of the holes and stress lines and the like. Let's go the other way.
So I was just saying to Alf that I don't know what you would use. Generally, there's a whole lot of products available, and I know Steve sells some at the shop here. The problem with gel coat on the outside of a boat is it is slightly porous, very minute holes in it, which is why it goes brown. You know, the stuff actually gets ingrained into the boat. And if you were to wet and dry down your brown boat, you will actually find underneath that it's probably white. So you can do that if it's really bad, and then you can use a cutting compound to polish it up from there. But as I was going to say, I feel that boats here tend not to get washed down very often. You know, if you're at the coast, you wash them down because you don't want salt interfering with it. But here we have another problem, and that is the muck in the lake. Just stays in there. Now, whether you could wash it out each day and that would stop it going brown, I don't know. But anything, if you wanted to make it look good, you probably have to use something that's abrasive, a cutting compound. And if it's really bad, you would need to wet and dry down. Maybe just 1200 wet and dry and polish it up. Once again, I use a lot of car cutting compounds for polishing these materials. I think they're better than a lot of the things that are sold as gel coat cleaners and so on. The gel coat cleaners are often a mild acid to try and clean those things there. But I think some cutting compound is probably the best way to do it. Yeah.
Perfect. And on that, guys, we do sell some stuff in the shop. Quick plug for the shop. The Dulon systems, which does exactly what Geoff's saying there. So it's a gel coat, a cleaner or a slight cutting compound to take the surface off. So that's dealing with your older gel coat. Then there are things to polish it up, and then their last step in their process is sort of a wax to reseal the highly polished area. So to try and fill some of that porous, porous marks on the top of the gel coat, so that it stays shiny and stays clean for longer. Available at the Canberra Yacht Club Boat Shop.
And once again, that's why if you use a automotive polishing compound, automotive swirl removing compound, they're doing the same thing for those paints. They're sealing the paint. Most industrial paints are really good to just spray them and leave them there. The surface finish is pretty much impenetrable, but if you start wet and drying it down to blend it into other areas, you lose that surface and you then need to go through the process of resealing. So a couple of different options there. But I just use my, I don't have a white boat, actually. That's probably the best thing to do.
Any other questions from the floor there? Oh, we got one from Patty in the chat. Just a second, let me bring that up on here.
Not a question, it's a thank you.
Oh, there you go.
Happy to do it, Patty. Thanks.
Very good. Well, folks, we might leave it there. Thank you so much.
Just one there from Mel. So how do you remove scuff marks without losing high gloss of paintwork? So, Mel, there's a lot of scuff marks I noticed on the boats around here that you can actually remove with acetone. I wouldn't put anything abrasive near the scuff marks without trying acetone or maybe one of the epoxy solvents. You can actually get a lot of marks off with that. I've noticed that in work I've done on trailer sailors where they've come into the jetty and so on, there's this sort of greasy, rubbery sort of feel of stuff, and you can often get it off with some solvent. Wear gloves with it and a mask, but you'll find that that might be the first way to go. If they're beyond that, you're then looking at doing some repair work, filling it, painting it and so on. Okay, I hope that helps.
Perfect. All right. Yeah. Thanks so much, Geoff, for joining us today. I really appreciate your depth of knowledge. Is phenomenal.